Okay, perfect. I can't hear you for some reason. Sorry, one second.
Can you hear me now?
Yeah, I got you.
How about now?
Yeah.
Sweet.
Sweet. Okay, hopefully Brad gets here in a second.
Hopefully. So I have a question about standard deviation.
Okay.
So like the sigma or like the O looking thing,
Yeah.
is that the standard deviation or is the standard deviation the equation?
No, it's the standard deviation. It's like the symbol for standard deviation.
Oh, and then the equation is to get like the sample size, sample mean or something.
What equation?
It's like this.
Oh, okay. So that's you get the standard deviation from that for the sample distribution. So use the standard deviation of trying to think of from what context that's from again. But it's the standard deviation from like the original data that they give you.
Mm-hmm.
And then the n being the sample size, and then that will give you standard deviation of that whole like I think it's the sample distribution.
Oh. Yeah, because that like threw me off the whole time. I was like, I don't know what I'm doing.
Oh no.
Hopefully Faith knows, but it's a good thing you do know.
Sometimes. Oh, we got the text from Brad. Oh, yep. He's asking if we're ready.
We are already here, bro.
I know.
I'll see you later. Bye, Savannah. Bye. Oh, is that your group? Yeah. Hello, group.
Okay.
All right. I'll see you later. Bye. Bye, Dan. Yeah.
I think he's still trying to figure out how to work these things. Okay, let me pull up the reading real quick so I can actually reference it while we're talking.
Yeah. Okay, so what other questions did I have? Like the whole thing was basically my question. Like, what? So I think like I should definitely get with the tutors to figure out what all of this means.
Yeah, that might be a good idea.
Yeah.
Yeah, I don't know. The thing is, I've done quite a bit of this before because we did stuff like this for a genetics class I took. So it's like, oh, okay, I get it. So I've already gotten to do a lot with this stuff, so that's why it just clicks a little bit easier.
Oh. Yeah, probably. Because this is like my first math class back since my mission. I'm like, oh no.
Oh no.
Oopsies. Yeah. But it's good. It like helps me work hard.
That's good.
Yeah. It's pushing me.
I'm trying to still like find a better explanation of that standard deviation for this. Okay. Yeah, so the equation is for the standard deviation of the sample means. So it's like when you did that applet thing, on the other page and how it did on the second chart, it was like random 25 samples, and then the next one was the average.
Hey, Brad. What up?
Hey, Brad.
What's going on?
Not much.
We're just talking about standard deviations.
Just chilling and standard deviation, huh? Cool.
So exciting. Okay. So, okay, cool. So now to
okay, so what problem you guys on?
Well, we haven't started anything yet.
Oh, perfect.
Because we were just kind of waiting for you.
Okay, so I'm gonna pull up the homework assignment right now.
Okay.
Okay. And Brad left.
Oh, I'm still here.
Oh, okay.
Yeah, I just changed the page.
Okay. Let's see.
Okay.
Okay.
Perfect. So everyone all set?
Yep.
Yeah.
Yes, I am.
So number 7's kind of weird since we all just kind of like picked our own numbers. But so what did you guys get as a mean for your sample?
Oh, I haven't done that yet. I thought we were gonna like do it as a group,
Oh,
but I can
okay.
do that right now.
Oh, yeah. So I'm really confused because it's weird because on the page it says to do the second part as a group, but on her instructions it says to do them before we get to the group.
Oh, really? Because I had just read it like do it as a group, and I was like, oh, okay.
Yeah,
But I
like,
can do it really fast.
okay, no, that's fine. Like this one's pretty simple.
Plus.
So you're supposed to use your own internet usage times?
That's what I thought I read the first couple weeks, and that's what I've been doing. So I've just been doing them before, and then we just do the quiz together.
Mm-hmm.
But I don't know for sure.
Okay.
I'll check again real quick while you
Okay.
That's probably what we're supposed to do.
So I got the mean of my sample is 44,600.
Okay.
That's your mean?
So everyone's gonna get different ones because we all picked 5 different ones.
Okay. Where are you guys getting this information at?
That chart above number 7. It's like all of them, and it says there's like number 1 is 45,000, number 2 is 39,500.
Mm-hmm.
Yep. Are you seeing that, Brad?
No, I'm not. Okay.
We're on lesson 6, right?
Yeah, lesson 6 homework. Okay. Yeah, I have the question. The question.
Oh, not on the homework. It's the
preparation.
Okay.
Preparation assignment.
Okay. Number 7 on the homework is the exact same question.
Really? That's weird.
Yeah, I think with just different stuff.
Okay.
Okay. Oh, gotcha.
Okay.
Great. Okay, so the mean of mine was 44,600. What did you get, Faith?
I got 43,420.
Okay, I'm just calculating mine right now.
Okay. Did you guys go to the devotional?
Yeah.
Yes, I did.
Wasn't that good?
So good.
Yeah.
It was like really
awesome.
intense. Like, get rid of all of your pride.
Right? Holy crap.
Oh, shoot. Okay, so I got an extremely large number.
Okay.
I don't think I calculated it right. So, let me do it one more time.
Okay.
Sorry.
So you just like have the 5 numbers and then you divide it by the number 5.
Yeah, that's what I did. It gave me like something to the 22nd power. Like that is a huge number.
Yeah. I feel like that's not quite right.
You add them up?
Mhm.
Oh yeah, that's what I did. I had multiplied them.
Oh.
That explains it.
That might make a difference.
All right, you get 42. I got 42,760.
Okay. So then on B, it says this graph illustrates the sampling distribution of the sample mean. There are a lot of possibilities.
Yeah.
Mark a spot. So
So it was kind of like on the left side.
Yeah, mine was too.
Same. Okay.
And then it says, does your sample mean to appear to be unusual? And it is not unusual.
No, it is not.
Perfect. Okay. And
Oh, should I explain why? It's kind of like obvious.
yeah.
Yeah, it fits in that bell curve.
Uh-huh.
Okay.
And then for D, compare your mean from 78 to the means obtained by at least 3 other individuals.
Yeah.
And what do you notice? In practice, you only get to see the means from the samples you draw. You do not get to observe any other mean that could have occurred. Okay. So we all had normal means, and that's a good thing. So
They were a little bit low, like they were on the left side of the bell curve, so that's interesting.
What would cause any of these to be outside the bell curve?
If they were just kind of outrageous, like if someone made, you know, like $200 or $2 million,
Yeah, but
and
nobody
you
did
like
that.
average that out, it would just be crazy.
Mm-hmm. Okay.
perfect.
Okay, so then
So start out number 8.
number 8. This one's hard.
Okay.
So the Graduate Management Admissions Test, or the GMAT, is used as an admission criterion in many Masters of Business Administration (MBA) programs. The scores on the GMAT are usually distributed with a mean of mu 529 and a standard deviation of sigma 115. Consider a simple random sample, or N10, students taking the GMAT. So then it says, what is the shape of the distribution of the sample means for all such samples? So it would be like normally, it would be like a normal distribution, right? Like a regular bell-shaped curve.
It should be right.
That's what I put, because you're taking it from a normal, well, I guess, which is kind of the answer for B, but you're taking it from a normal distribution already, so all of your sample means are going to be normal.
Yep.
Yeah, and okay, sorry, one more time. What would cause it to give you a different shape other than a bell curve?
Like if they were skewed a certain way?
Yeah.
Like if you had giant outliers, like if you had like something that was just outrageous one way or the other, it's going to throw your whole average off. And so then your point is going to be off.
So from this example, what tells us that it'd be a normal one?
So it says in there the scores on the GMAT are normally distributed.
Yeah, so they have. Just that right there tells you.
So it's already telling you that the original data is normal, and then according to the rules of whatever statistics, I guess, that if you take sample means from there, those sample means are going to be distributed normally as well.
Okay, cool.
T.
And so that kind of answers B too, huh?
Yeah.
So what is the mean of the sampling distribution of sample mean scores for all such samples?
So is this where you would use like the equation that we were talking about before?
No, that's for the standard deviation. So that's the one you would use for D. So in this one, it explains in the rating that the mean would be the same. So it would be 529.
Yeah.
Oh, okay. I get you. Oh, yeah. It's right there. So, sorry, guys.
No worries.
Okay. So D says, what is the standard deviation of the sampling distribution of the sample mean scores for all such samples? So that's when you would use the what do you call it? The equation, right?
Mm-hmm.
What's this equation you're talking about?
Oh, it's like sigma divided by the square root of n.
Okay.
Yeah, it's in the readings. It's where they explain about how to find
Yeah.
the standard deviation thing, Bob. So.
So
So
did
you
you? Oh, go for it.
Oh, so it says like in the question that sigma is 113,
Mm-hmm.
and then you divide that by the square root of 10, right?
Mm-hmm.
So you get 35.73.
Yep.
4, 5, no, 7337376.
Yeah.
Yep, that's exactly what I got.
Perfect.
Cool.
So we got that done.
Alright, let's go to the group test.
Yes.
Okay.
Okay.
I completed the individual, yes. I actively participated. Yep. Okay. When taking samples of n, when n equals 5, what is the shape of the distribution means histogram when the parent population is right skewed?
What was the shape?
So it would be skewed right.
I would think so.
Because it says the parent population is right skewed, so.
So it'd be skewed, right?
Mm-hmm. That makes sense to me.
Me too.
Now, how does changing n affect it?
So the more like samples you take, the more it's gonna reflect a normal distribution. But actually, if it's already skewed, it'll be different.
Okay.
One second, I'm gonna pull up that applet thing real quick and just throw.
And see what it does.
Yeah. And throw that in there real quick.
Okay.
Which is really nice that they give us all these like little applet things that just do it.
Definitely.
Okay.
That's weird.
Yeah, so it's still right skewed, even with 5.
Okay. So now what about with 100? Would that make it more normal because there's more samples, or would that keep it right skewed because it's already right skewed?
I feel like it would still stay right skewed
because that's kind of like the normal for this thing, right?
Yeah.
Okay.
Does that make sense to you, Kimberly?
Uh-huh. Yeah, I just did it in the applet too.
Okay, same. Okay.
Okay.
So does that give us to 5 then?
So if the histogram's parent population is normally distributed and you got 100 samples, it'd be a normal, right?
Yep.
Wait, for number 4, when it's right skewed with n, it would be normal?
No, it'd be right.
No, 5.
Oh, I was like, what? Yeah, normally distributed is normal.
Okay.
Okay, so when would the distribution of means be normally distributed? Choose all correct responses. Data are drawn from a population that is normally distributed and the sample size is small. Data are drawn from a population that is normally distributed and the sample size is large.
That's one of them, right?
Yeah, I think both of those would actually both qualify.
So wait, a small sample size would make it normal?
Well, the fact that it's drawn from a normal distributed population.
Oh,
anyway,
yeah.
Both are automatically true.
And so anything right skewed wouldn't be because it's normally distributed.
Exactly.
Okay.
So the first 2 are correct.
Yeah.
Okay.
And then like the other 2 right skewed wouldn't even make a difference. Like those are both wrong. because they're not normally distributed.
Mm-hmm.
Yep. Okay. So then 7, which of the following gives the best explanation of the central limit theorem? If the parent population from which the data are drawn is normally distributed, then the sample mean will follow a normal distribution. For a bell-shaped data, approximately 68% of the data will be within one standard deviation of the mean. That one's definitely not it, because that's
Mhm.
the other
Mhm.
law, so I'm not even going to finish reading it. If the sample size is large, the sample mean will be close to the population mean. If the sample size is large, the shape of the sampling distribution of the sample mean will be approximately normal.
I think it was the first one, wasn't it?
I think so. I'm going to look at my notes real quick.
Yeah. It should be, shouldn't it be, if it's large, it equals the mean of the population?
Sorry, can you say that one more time, Brad? Sorry.
Shouldn't it be that if the sample size is large, then the shape of the sampling distribution would be equal, approximately
Normal.
normal? Yeah.
That's kind of what it says, like in the
In the in the definition.
Yeah. Yeah. So the last one.
Yeah.
Yep. Sounds good to me.
Okay. Let x be a random variable with population mean of mu 10 and the population standard deviation of sigma 6. Suppose the sample size of n 36 is drawn from this population. What is the mean of the distribution of sample means? So this is the equation, right?
This one's still asking you for the mean, so it would just be mu.
Oh, so it's 10.
Okay.
Yeah.
And now the standard deviation, what you would do,
That's just 6.
sigma. Wouldn't it be sigma divided by the square root of 36?
Yeah. So wouldn't that just be 1?
Oh.
Would it be? So let's
No.
do
Sorry.
36 divided by the square root of, oh, whoops, no.
Yeah.
It'd be 6 divided by the square root of 36. Oh, you get 1.
Does that make sense, Kimberly? Sorry.
Yeah.
Oh, because it'd be 6 divided by 6.
But I'm trying to think, like, would that really be 1? Because the standard deviation, like when it was 1 in the other thing that we did, that was like pretty normal. So that's like a pretty normal answer.
Yeah.
Standard deviation of 1.
Well, if you do, so the square root of 36 is just 6. So you would be doing 6 divided by 6, which would equal 1.
Mm-hmm.
Makes sense.
Yeah, it's weird.
Yeah.
So you were going to put your answer as 1.000 to get 3? No.
Oh.
1.00 to get 3 decimal places?
I guess so. Why are they asking for 3 decimal places?
I don't know.
They usually don't ask that unless we need decimal places.
That's true. That kind of throws me off a little. I don't know what to do.
It's the standard oh, wow, I just cannot talk. It's the standard deviation of the distribution of sample means, right?
Yeah.
And that's the same question that we did at the very end. What is the standard deviation of the sampling distribution?
Yeah. So
That should be right.
yeah.
So just like 1.000.
I
Yeah,
guess.
that's what I did.
Okay.
Okay. Okay, go for it.
So regardless of the distribution of the population, if the sample size is large or n is greater than 30, what would be the straight shape of the distribution? Wouldn't it be normal?
That's how I understood it from the reading.
Yeah.
I think so. If the sample size is large, because it said like in the reading, if the sample size is large, then it should be normal.
And wouldn't that be the central limit theorem? Okay. Okay.
Submit.
Okay.
Ready, guys?
All right.
Yeah.
What?
Who said it was right skewed? Just kidding.
That was me. Sorry, guys.
It's okay. Hey, B's get degrees. Just kidding.
Okay, well. Okay, I guess I didn't understand that right skewed thing.
So is it pretty much just if they have a large number of samples, it's just always normal?
Yeah, which I guess makes sense because if you look at our answer that we did for 10,
Mm-hmm.
Mm-hmm.
And
11.
that would make sense for number 6 too, where it says the data drawn for a population that is right skewed and sample is large, it would be
Yeah.
normally distributed too.
Right.
Okay.
That
Yeah.
doesn't matter.
But we got the 1.000 correct, so that's good.
All because those decimal places.
Okay.
Well, at least we understand it.
Yeah,
Yeah, that's true.
Okay.
not bad. Okay. Cool.
So I guess we'll just see you on Thursday at 1?
Yep. That works for me.
Good work.
Awesome.
Okay.
Well, I'll see you guys then, and hopefully I'll understand it better with the tutor and stuff.
Okay.
Alright, guys.
Well, good luck.
All right. We'll see you guys.
See you guys.
Bye.
Bye.